Hello, and welcome to the ALCTS webinar, Introduction to R for Libraries. This is the third and final part of this series. I'm Lisa Lorenzo, a member of the ALCTS Continuing Education Committee, and I will be your host for today's webinar. Our presenter today is Clark Iakovakis. Clark is the Scholarly Communications Librarian at the University of Houston Clear Lake. He has worked in both academic and public libraries since 2007 as a page, library assistant, and research and instruction librarian. He has presented at ACRL and ALA on topics pertaining to usability and incorporating data into assessment. He is currently achieving his master's degree in history, and he does not come from a technical or computing background. We're excited to have him with us today. A few logistics for today's presentation. All attendees are muted to prevent background noise, and we do not have interactive chat capabilities. You may, however, comment on today's presentation using Twitter. The hashtag is ALCTSCE. We do not monitor the Twitter feed, so if you have questions for our presenter, please type them into the questions box on your screen. We will have time for Q&A after the presentation. There is also a handout and exercises available to accompany this presentation, which you can download through the webinar tool panel. You should have also received the handout and an accompanying CSV data file in an email from ALCTS this morning. This webinar is being recorded, and you will receive an email with links to the recording and presentation slides shortly after the presentation concludes. And now, here's Clark. There will be a slight delay as we change presenters.
All right, thanks so much, and welcome everybody to this third installment. I hope that you've had some fun over the last few weeks learning R. I'm assuming that some of you have had some frustration as well, and that's actually a good thing. That's a phase that all of us go through as we're learning R, and it just means you're making progress. So hopefully you've had some time to review the recordings a couple of times and maybe go through the handouts, and I'm really excited to bring you this last session on data analysis and visualization. A couple of things before I start. I want to repeat something that I said last time, which is this session is not really designed for you to follow along with me as I'm going. I move at a very fast pace, and that's actually deliberate. I really want for this to be a sort of resource for you. So, you know, like bookmark the recordings and then you can go back and work through them. The slides move along in conjunction with the handouts. So, you know, you'll be able to watch a bit of the webinar and then pause it and work with the handout. And that way it serves as a kind of resource for you to draw upon as you continue learning and using R. The second thing I want to say is that I created another test data set for today's session, and this is ebooks, ebook usage data. It's about 10,000 observations or 10,000 rows of ebooks. And one caveat to that is that's a pretty random sample, so it's not representative of ebook usage at UH Clear Lake. And the second thing about that data is it does not include any ebooks with zero usage. So all of the items in that data have some usage. So with that said, let's move along. That's me, again, Scholarly Communications Librarian at UH Clear Lake. This is the outline for today, and again, we're packing in a lot. We're going to be doing some cleanup of character strings using the stringr package. We're going to be grouping and summarizing data with dplyr, and we're going to be visualizing data with ggplot 2. So everything that we're covering today comes from an external package. Each one of these packages is included in the tidyverse installation. So if you haven't already, go back and watch the second recording and install tidyverse, and whenever you load tidyverse into your R session, you're automatically loading these three packages in. So you can use all of the functions that we're talking about today. If you don't load it using the library function, then you're going to get an error message that says could not find function. Yes, it still is overwhelming, I'm sure, but as I said earlier, this session has a long handout with many examples, so work through that, and it will begin to diminish, I assure you. So let's get started. We're still here in the tidying and transforming phase, and before we move on to the visualization. First thing you want to do, as usual, is to load in the ebooks data. So as you download that CSV file from the email that you have received this morning, wherever you saved that file, that's going to be your working directory. So as we talked about last session, you call setwd and set the directory that you have the data file saved in. And then you use read.csv to read in the data file. I want to mention that you can copy and paste commands from the handout that I gave you directly into your R session. So you don't have to type all of this out. One thing about this is be sure and rename that file to just ebooks.csv, and that way you'll be able to use this expression. So as usual, we always set strings as factors to false, and we're coercing the ISBN columns to character vectors, and I discussed that last session. Okay, let's talk about stringr. This is a package that is essential for working with what are called character strings. That just means, like, if you have a title or a subject heading, that's a string of characters, right? So the title Macbeth is a string of MACBETH. The stringr package is included in the tidyverse install, as I mentioned. And library data has a lot of text, a lot of character strings, and a lot of these are super messy for a number of reasons. So we have titles, which include journals, databases, books. We have subject headings. We have ISBNs and ISSNs. As we discussed earlier, even though these are digits, they're treated as characters. So as we'll see in the coming slides, sometimes these character strings need a lot of work. Of course, install the package either individually or as part of tidyverse, and then load the package. Okay, so we've read in our ebooks data. That means we have an object in our R environment that we call ebooks. It's a data frame that consists of a number of vectors. Each one of these vectors is what we would call a column in Microsoft Excel. And one of these columns is user sessions. And what this does is it gives us how many sessions have been accessed per ebook. If an ebook has 12 user sessions, that means someone has accessed it 12 times. First thing I may want to do is to take the mean user sessions for all ebooks and say, on average, how many sessions does a book have? Well, if I run this expression, I'm going to get this warning message, and it tells me in this mean function, the argument, which is the vector, the user sessions vector, the argument is not numeric or logical. I can only do a mean on something that's a number or logical vector, so I'm going to give you NA. Why can't I get the mean user sessions? Well, if I call class on that variable, it's going to tell me that that was read in as a character vector, and the vector class is not numeric or logical. All right. Why did R read this in as a character? Well, this goes back to the way that R reads in data with read.csv. It goes through each value in a vector. So it scanned through each one of these user sessions and it evaluated it. Is it a number? Is it a logical, true, false? Is it a character? If all of them are numbers, then the class of that vector is going to be numeric or integer. Well, so I call unique here. So this is showing me all of the unique values within the user sessions vector. They all look like numbers to me. Why did R read it in as character? And the answer is they're not all numbers. The vendor included commas in the thousands place. So that one little comma made R read this vector in as a character. And actually it did that for total pages, pages viewed, and pages printed. So I called stir here on these columns so I can see what their class is. You can see they're all character. The only one that's not a character is pages copied, and that's because no one ebook had more than 1,000 pages copied. So that vector was read in correctly as an integer. The rest are character. So what we have to do is remove that comma and then change the class of each of these vectors into an integer. That way we can do operations on them, like see which one has the most user sessions, find out what the average is. If we don't do that, then we're not going to be, if we don't do those steps, we're not going to be able to do those operations. In other words, we're not going to be able to do any kind of usage analysis. String replace is a function that will take care of that for us. One thing I want to point out, all of the stringr functions start with str. This is not the same as the stir function that we've been using since session 1. Stir just gives a display about information about an R object. Here, the str is short for string. So I'm just going to pronounce it as string. So what string does is, a string replace does is find and replace character strings. And if you call help on it, you can see that it takes 3 arguments. It takes the character string, takes a pattern, and it takes a replacement. So let's talk about what that means. The character string is the original vector, and you have to use a vector here. In other words, you can't load the entire ebooks data frame into string replace. You have to specify a column within that data frame. The second is it looks for a specific pattern, excuse me, and the third looks for a replacement, so what to replace it with. Here's an example. For the vec, I'm going to create a vector with 3 elements, 800, 900, and 1000. And you can tell these are characters, first of all, because they have quotes around them, and second of all, because the third one has a comma. And in R, numeric vectors cannot have columns. Then I'm going to create a second vector I call vec2, and I'm assigning to that, I'm using the string replace function. The string is vec, the pattern is a comma, so you see you have to put that in quotation marks. The pattern is a comma, and I want to replace that with nothing, which is an empty set of quotation marks. And what that's going to do is just remove the commas from any value it finds in that vector. So in other words, it's going to look like this after I run it. But there's a problem here. We've removed the comma, but the vector is still characters. And if we call class on that, we can see it's still a character, which means we can't do any mathematical operations with it. To fix that, we have to use a series of functions called asInteger. And what this will do is coerce that vector into an integer class. So there's asInteger, there's asCharacter, there's asLogical. These are good functions to know because you have to have your vectors in the class that you want them in order to use them properly. So if I replace vec2 with asInteger vec2, that's just going to overwrite my vec2, but it's going to coerce all of these values into numeric elements, and that means I can finally find the average, add them together, or whatever I want to do. Now I know this may sound overwhelming or sound like a lot of steps, but this is a very essential and important and common problem with data. Very rarely does data come to us clean, and we have to do this kind of string cleanup to get it in the format we want it to be in. So that's how you do it on an individual vector. What if we want to do it on the entire data frame, on these 4 columns that are problematic columns? For this, we're going to use the mutate function. I introduced mutate last time. This is one of the dplyr functions. And what mutate does is allow you to change or modify existing variables or create new variables. So I'm going to walk you through what I'm doing here. I'm calling mutate on ebooks. I'm using the exact same variable names, total pages, pages viewed, pages printed, and user sessions. So that means they're going to be overwritten by whatever functions we perform after the equal sign. And here's what's going on. I'm using string replace on that vector, on the total pages vector. I'm looking for any commas in all of the elements. And I mentioned earlier R is vectorized. That means that it's going to look through each one of the elements of this vector and make any changes I tell it to. So it's going to look for comma in each one of those, and it's going to replace it with nothing. Then I'm wrapping that entire function inside as integer. So after it removes those commas, then it's going to coerce it to an integer, and then I can actually do mathematical operations on it. So I'm doing that with all 4 of these columns, and I think you'll be amazed to see that if you run this in R, it's going to take about a second or less. So throughout the last few sessions, I hope you've been starting to see how much power you have over your data using R as opposed to traditional spreadsheet software. So this is one of those examples. Now, of course, you have to get to the stage where you can write expressions like this, but once you get there, now whenever I open up a data set from this particular ebook vendor, I run this operation immediately. I just have it saved in a R script on my computer, and it's done. And then I can move on to more important things. So that's string replace. I'm going to introduce a couple of other important string functions now. The next string function is called string sub. So what this does is it takes a vector, again, just like string replace. It takes a starting character and it takes an ending character, and it grabs the characters in between those points. That's what's called a substring. So here I have ebook call number, and you see I have the 1 in brackets there. That means I'm just taking a subset of that vector, the first element, which is M, music book. Let's say I wanted to extract just the first character there. So I just want to know what the Library of Congress call number class is. I call string sub on that vector, which is a vector of 1 element, start with the first character and end with the first character, and that will give me M. Now, in the same way that we used mutate with string replace, we'll do the same thing with string sub here. So here's what I'm doing. Again, I'm mutating ebooks, and I'm replacing my existing ebooks with the mutation. This time I'm creating a new variable, and I'm just going to call it LC class. And then I'm calling string sub on LC call. Remember, LC call was the existing data vector that was in my ebooks data set. That was just the call number for each individual ebook. Start with the first character and end with the first character. So after I do that, I would just call head on it. What head does is just print out the first 6 elements of a vector. So I'll call head on it, and it shows that now I have my LC call number class. And that is going to be very powerful and useful, as we'll see. We're going to use this LC class to run some visualizations on our data and some analysis. So that's string sub. 2 more functions in string R I want to review. One is called string trim, and what this does is remove white space from the start or end of a string. White space can get entered into a string for a number of reasons, accidentally, sometimes user input, sometimes it's a machine input. The problem is if you ever want to merge 2 data sets according to that, that variable, like let's say you had print books and ebooks and you wanted to merge by ISBNs, or if you had your ebook usage data and your ebook holdings data and you wanted to merge by the document identifier. If there's any white space before or after, the merge is going to fail. So string trim is a quick way of getting rid of that white space. So here I just create another vector, and you see there's a space before the A, after the B, and before and after the C. That's what it looks like when I print it. But when I call string trim on it, it automatically removes that white space. Very handy, because you'll be amazed how many strings have spaces on the beginning and end. Finally, string detect. And what this does is detect the presence or absence of a pattern in a string. In other words, it will go through an entire vector of values, and it will say, does this pattern exist, true or false? So here I create a 3-element vector called titles. And when I call string detect on it and say, look through titles and return true or false if that vector includes the term Dracula, right? Or the pattern, actually. So obviously it's false, true, false. And as we saw last time with is NA or duplicated, there are many functions in R that return these true, false values. And they can be very helpful for creating subsets. So one thing you could do is wrap all of that in which, and which will say, which will return the numbers in which the result is true or false. So in this instance, the second value is true, so it prints out 2. So you can use this if you want to quickly see, okay, which one of these values are true or false. But even more powerfully, we can use the filter function. And filter is another one that I introduced in session 2. And filter is a powerful way of creating subsets of your data. So let's say I wanted to create a data frame that looked through the titles vector and found every instance of the term chemistry. This is how I would do it. First, I'll create the new data frame, ebook science, call filter on ebooks, and then use the string detect function to look through each title, and if the term chemistry exists, add it to my new data frame. If it does not, then filter it out. Now if I call head on my recently created ebook science data frame, we can see that that term chemistry exists in each one of these titles. This can be an extremely powerful way of creating subsets. So you could run this over subject headings. You can add multiple items in that pattern if you use the OR operator, which is just a pipe. That way, it's a really robust way of creating a subset of your data according to words. So that's all for the suite of stringr functions. Next, I'm going to move on to doing some more complex analysis in dplyr. We introduced several dplyr functions last time. These are 2 more, group by and summarize. What group by does is clusters the data set together in the variables that you specify. For example, I can create a new data frame by LC, and I'm grouping my ebooks data by LC class. And what that means is all of the items with LC class A will be grouped together, B, C, D, and so on. On its own, this just creates a grouped data frame. So it's the same number of items, 10,000 items, but they're all just grouped together. Really, it should be used in conjunction with summarize, and that way we can actually get summary information by group. So what can we learn about what's going on with books of call number class A, call class B, and so on? And that's where summarize comes in. Similarly, summarize is not particularly helpful without group by, because otherwise there's only one group, your entire data set. For instance, if I call summarize on ebooks and I say, okay, I want to summarize ebooks, give me the mean user sessions. Well, that's just going to print out the mean of all of the user sessions. That's exactly the same as if I just called mean on ebooks $user sessions, exactly the same. What I want to do is use summarize on a grouped data frame. So remember earlier we grouped by LC according to LC class. So here what I'm saying is summarize that grouped data frame by LC, and I want a new column there. Let's call it total sessions, and that represents the sum total of user sessions per call number. And it's going to then return that in the form of a data frame. So I'm going to have a new data frame in R called user sessions by LC, and it's going to look like this, with one column giving me the LC class, the second column giving me the total number of user sessions per LC class. So you can see that out of that entire data set, there were only books of call number class A. I only had 48 total sessions. This is a little bit more useful if we arrange it. You may remember last time that arrange is another dplyr function. So what I'm saying here is I want to view user sessions by LC, but I want it arranged in descending order according to total sessions. So that will tell me the usual suspects are up at the top. H, Q, and L all have the highest number of user sessions. And similarly, down at the bottom, we have U, C, A, and V with comparably fewer total user sessions. We discussed last time using the pipe as a way of combining multiple dplyr operations. And this helps so you don't have to create these intermediate kind of junk data frames like by LC, which is just a grouped data frame, and it makes for easier to read code. Here's what I mean. Rather than create a by LC separate grouped data frame, I'm going to create a new one called by LC summary. This is going to get ebooks, and remember you read the pipe operator with the word then. So get ebooks, then group ebooks by LC class, then summarize it. And when I summarize it, I want to create 3 different columns. The first column is going to be count. This will give me the number of books per call number. The second column is total sessions. This is the sum of the user sessions per call number, what we just did. And then the third is average sessions. That's the mean number of user sessions per call number. And remember, because we're grouping by, all of this is going to be summarized according to that group. And this gives us this table. Now we can start to kind of look at some patterns. And that's all that this is about. These are different ways of figuring out what's going on with my data. Let's dig into it. Let's figure out if we can discover some patterns. And you know, you're going to have a lot of fails, and you're going to have a lot of times you do all of this work and you're not going to discover anything particularly interesting. And that's all right. Like, it's our intent to see what we can discover and then translate that into decisions. So does that mean we need to purchase more ebooks in a particular class? Does that mean we need to, you know, say roll out a ebooks instructional program for particular disciplines? Whatever you do with that is up to you. But the intent here is just to come up with some information. So here we can see that H has the highest number of items and the highest number of user sessions. And Q has the highest average sessions there, you can see with 4.68. So this either means that these items are getting more heavily used, or at least some of them are. Perhaps that average is being skewed, dragged up. Now, if you're a statistics person, you have many other options. R is a very robust statistical analysis software. So you can include median there, minimum and maximum, standard deviation, variance. And that would look something like this, where we have ebooks grouped by LC class and then summarized by all of these different variables. And that gives us this data table here. There's a couple of interesting things I noticed when I was looking through this, especially when I was comparing P and Q. You see P has almost as many items there in the count column, which is the second one, as 1,067. And Q has 1,187, but their stats are dramatically different. So what I did is I used filter from the dplyr package, and I filtered that summary table to where I'm only going to be looking at items where the LC class is P, or that's what the pipe represents, or the LC class is Q. Now, very interesting here, despite they having a comparable number of items, Q has a much higher standard deviation and variance, much higher. So this means that the usage of P books is lower and much more evenly distributed, and that high variance means that Q has at least one serious outlier, and that's the case. So again, that in sum, group by and summarize are good ways of coming to insights about your data. It's not always about visualization, although as we're about to see, visualizations are very cool. You can learn a lot from them. But typically a data analysis project goes from running tables to doing visualizations to going back to tables, going back to visualizations until you're kind of catching on to some underlying trends. So let's talk about visualization with the ggplot2 package. Now, base R includes several functions for quick data visualization, and that's the same was true when we were talking about dplyr. You can do a lot of what dplyr does with base R. It's just honestly a lot harder. And most R users at this point consider ggplot2 to be the most elegant and versatile way of visualizing data. ggplot2 implements what's called a grammar for data visualization, and dplyr did the same thing for data manipulation. So you're learning this grammar where we say filter creates subsets, a select selects different columns, mutate changes the underlying data. That's a grammar for manipulating and working with data. And we're going to learn the grammar for data visualization as is implemented with the ggplot2 package. This one is also created by Hadley Wickham. So as always, we're going to start by loading the package. So we call library ggplot2. When you create a plot with ggplot2, it plots directly into the plots tab, which is in the navigation pane in the lower right. You can also assign the plot to an object. So you can say like my graph gets, and then put in a ggplot expression. And then if you want to look at that plot, you can call print on it, and it will print again down there in the navigation pane. But we're just, at this point, working with objects. So if you want to save it as something external, to like a file on your hard drive, you do that using ggsave. And we'll talk about this at the very end. All right, so ggplot2, that's the name of the package, but the function call is just ggplot. And what ggplot does is create an initial coordinate system. In other words, a kind of blank canvas. So I call ggplot on my data, and that's what I'm going to get. It's just completely blank because it's waiting for me to add layers to it. And those layers are added with a plus sign. And here's what that looks like. Before I get to that. Data is visualized in the canvas using geometric shapes. And this is part of the grammar of data visualization. Those geometric shapes are called geom functions. And if you think about it, that's all that a data visualization is. For example, a bar plot is just bars, geometric, just rectangles. A line plot is just a line. A scatter plot is just a bunch of dots. So ggplot2 contains over 30 geoms. Amazing stuff, stuff that you never knew you could visualize is included in ggplot2. And accordingly, bar plots use geom bar, line plots use geom line, and so on. So this is what it will look like, okay? We're adding layers of bars to this plot. So we call ggplot2 on our data, which is ebooks. Then we're adding a function of geom bar. And I'll explain what all of that means inside geom bar in a second. So essentially, we're telling it draw some bars on top of our canvas according to these specifications. And here we're looking at LC class, and it's a frequency distribution. So here's what I'll come back to this plot in a second after I describe what was inside that expression. Now this is going to be kind of complex and jargony, so I'm going to do my best to explain what it means. Each geom takes what's called a mapping argument, and that mapping argument is paired with AES, which is an aesthetic map. And what that means, what I'm doing here, if you look at that expression there at the bottom, I'm mapping LC class to the x-axis. That's why it appeared down there, A, B, C, D, E, F, G, along the x-axis. So what ggplot is doing is it's looking for LC class in the data, and I load my data into that initial ggplot function call. So it's looking for a variable called LC class, then it's scanning down it, and it's performing, it's putting each one of those values into the x-axis. It'll make a little more sense when we actually look at it. So note that count on the y-axis is not a variable in the original data set. What's happening here is geom is doing what's called binning the data. So it's going through each ebook, and if the LC class is A, it's going to bin it in A. If it's B, it'll bin it in B. And then it's going to plot the bin counts. So I think the important couple takeaways so far are that we're calling geom, which means we're going to end up with a bar plot, and we're mapping LC class to the X aesthetic, the X scale. And you don't have to specify mapping equals AES, so that's going to be omitted. There's going to be a few more examples here to help you hopefully wrap your head around what's going on with this. So I'll start by talking about what are called univariate geoms. Univariate means one variable. We just saw an example of that. We were only looking at amount of items in each LC class. We weren't looking at anything else. We weren't looking at user sessions. We weren't looking at titles, pages printed. We're only looking at LC class. We're going to look at another one here. This is looking at user sessions. So I'm calling ggplot on my ebooks data, and I'm adding a histogram geometric shape, which is also a bar plot. And I'm going to map user sessions to the X aesthetic. And it's going to look like this. Not very pretty. And I get an error message. Why does that look so bad? The problem, as anyone who's looked at your collections knows, the overwhelming majority of items have a small amount of usage. Now, if I had included ebooks with 0 user sessions, that would have been absolutely dwarfed by the number of items with 0 user sessions. And so that throws off the scale. Now, I'm trying to teach ggplot, the basics of ggplot, but at the same time, I'm doing this for librarians specifically. So I thought about using different data that would be easier to visualize, but then I thought, this is a common problem. This is something that I run into all the time. And so I decided to continue using it because it's just the fact. That's just the way things are. The vast majority of items have little to no usage. So I kept it in. That's one reason I kept it in. And the other reason I kept it in is it illustrates a way to get around this problem using ggplot. So it can actually show the power and versatility of ggplot. And the way that we're going to get around this problem and create a visualization that is actually meaningful is to change the scales on the X and Y axis. And we do that in this way. We call ggplot again, and we call geom histogram. I changed the bin width there. I'm not going to talk about what that means. But then look at the last 2 lines of that expression. I changed the scale of X to be what's called a logarithmic scale, and I changed the scale of Y also to be a logarithmic scale. So look at those scales on the X and Y axis. And if I was publishing this data, I would have added the 100 there. It goes from 10 to 100 to 1000. So by default, it's leaving that 100 out, but it's super easy to add it in. So what that means is from the 0 to 10 on the X axis, those items, and then the over 1000 on the Y axis, over 1000 ebooks have fewer than 10 user sessions. Again, user sessions is on X, the horizontal, and the count is on Y, the vertical. So over 1000 ebooks have fewer than 10 user sessions, and a very tiny number have over 1,000 user sessions. So I hope that makes sense to you. We're going to not leave that behind, that concept. So let's move on and look at a couple of other illustrations. That demonstrated the versatility of ggplot2 in one way. Another way ggplot2 is incredibly versatile is in the different types of data visualizations that you can do. So we were looking at a histogram, but if I just replace that geom histogram with another type of geom, this is what's called a frequency polygon, I can get a completely different visualization. And this is a line plot representing the number of user sessions. Or I can replace it with what's called geom density. The point I really want to emphasize is that each of these shows us a different aspect of our data, and that can be incredibly insightful. So it's worthwhile to experiment with different geoms and see if you can discover insights. And all you have to do is swap out that argument. All right, that's univariate geoms. I want to spend a little time talking about what are called bivariate geoms. And bivariate just means multiple variables. So earlier we've been looking at LC call number class or user sessions, but what if we wanted to look at the number of user sessions per LC call number class? That would be a bivariate geom. So I want to take a look at higher usage items. So what I'm going to do is create a new data frame using my ebooks data. I'm going to just call it ebooks plot, and I'm going to filter ebooks and I only want items where the user sessions are fewer than 500 because there are those extreme outliers, and more than 10. So I'm going to add an ebooks plot, a new ebooks plot object. And then I'm going to plot user sessions by call number class. Here's what's going on. First of all, I'm using geom point. This creates a scatter plot. In scatter plots, each individual item is represented by a point on the graph. I'm mapping my LC class to the x-axis. So this is going to look like that first visualization we saw where A, B, C, D, E, F, G. And then I'm mapping the amount of user sessions per ebook to the y-axis. And I'm going to go ahead and scale this one also according to a logarithmic scale. And here's what we have. As I mentioned, just another way of figuring out some underlying patterns. So you glance at this and you say, okay, what are some things that stick out? P has no items with over 50 user sessions, and those seem to be evenly distributed, like we saw in our table earlier. G has very few items in there, but 3 of them have over 100 user sessions. So what's going on there? And then you go back to your underlying data. You can create a filter, and you can look at just G call number items, and you can say, what are these items in G that have such high usage? And then you can do whatever with that information. You can figure out, is it being used for a class? Do we need to purchase more items like that and add them to our collection, and so on. And just as we saw a variety of different univariate plots, we can do the same thing with bivariate plots. So rather than do just a geom point, which is a scatter plot, we could do a box plot. It's just an alternative way of visualizing the same data. And the same thing is, I really like this one. I think it just looks cool. But you can see the bigger parts of the item are those areas that are those ones that have more usage. So for example, P has more usage grouped towards 10, whereas Q is kind of stretched out along, and all of them taper off towards the end. With the exception of J. There are some in J that have more user sessions. Okay, we have now used 2 aesthetics. We've mapped variables to the x-axis, and we've mapped variables to the y-axis. We'll now map a 3rd variable to a visual aesthetic, or color. So the expression looks like this. Same as we've done before, only we're adding another argument here in AES. We're adding a color argument. In other words, we are assigning the name of the aesthetic, which is color, to the name of the variable, which is collection. And it's going to look like this. Collection. So here's what's going on with this one. What ggplot is doing is it is automatically assigning a unique level of the aesthetic. In other words, the aesthetic is color. So it's automatically assigning a color to each of the unique values of the variable, in this case, collection. So there are three unique variables in collection. There's DDA, was the item triggered by a demand-driven acquisitions. Is it purchased? Did a librarian actually purchase the title? Or is it subscription? Is it part of our subscription package? So we can see that most of these items are either purchased or part of the subscription, but there are a couple of high usage DDA items that we may want to check into. Similarly, we can use fill with geom bar plots to create what are called stacked bar plots. So here I'm calling the same exact function as I did at the beginning of this section, geom bar, the mapping LC class to the x-axis, and I'm mapping collection to the fill, and it's coloring in automatically according to those levels of the collection aesthetic. A quick way of getting a glance into how your data is distributed. So a lot of just at a glance, you can see that H and L have a lot of items that were purchased by librarians, which would definitely feel good to the librarian who is responsible for selecting titles for that call number. Okay, at risk of overwhelming you, I'm going to introduce one more way of visualizing a third variable aside from color, and that's called facets. And what facets do is create subplots of subsets of the data. So there's a lot going on here, and I'll just briefly describe it. So we have two different geoms here. We have a geom point and we have a geom smooth. And it's a bivariate visualization. What we're doing is looking at pages viewed, the correlation between user sessions and pages viewed. So we would expect that the more user sessions an item had, the more pages viewed. So we're visualizing that using a scatter plot with geom point, but we're also adding another geom. You can add multiple geoms to a single visualization. We're using geom smooth, which is kind of like a line of best fit, and it's taking the same exact aesthetics. We're then wrapping that using facet wrap to wrap that, create subplots according to LC class. And you have to, if you're going to use facet, read the help pages for it, because I just don't have time to describe it, but it's going to look like this, where each one of these subplots is a different call number, and you can see indeed the two are positively correlated, where then as user sessions go up, pages viewed go up, and so on. So you can quickly look at this at a glance and see how are people using ebooks in each of these different call number classes. Just as with dplyr, you can use ggplot with pipe, so I can create a filter of ebooks where I'm just looking at Q and P, then plot that according to a frequency polygon plot. I'm not going to describe everything that's going on here. I just want to illustrate the fact that you can use dplyr operations before you plot it, and that too leads to cleaner code, fewer objects in your R environment, and as you master the pipe, it'll come naturally to you what manipulations you want to develop before you plot it. Just a couple more slides here. Of course, you want to style your plot. You want to add a title. You want the scales to appear differently. You may want tick marks to be on certain numbers and not others. You have almost total control over the appearance of your plot. And this is called the theme of the plot. There are a number of pre-constructed themes, and you can look at those at this hyperlink. But if you call help theme, you can see there's dozens of different parameters. You can control, it's just amazing the amount of control and precision that you have. And you can add these to your theme call and basically construct your own custom theme. Finally, you want to save the plot with ggsave. In the same way, this is what we had to do with write.csv. You want to create a file on your hard drive, and you can do that. There's a number of different arguments here, like the height and the width, and do you want it to be a PNG or a PDF? I don't really have time to go over this last slide, but I really would like for you to come back to it. This will make working in RStudio a lot easier. Some shortcuts for jumping from the script pane up to the console pane, shortcuts for fixing your indentation. You can do that automatically. I do want to say, rerunning the previous chunk of code by pressing Control-Shift-P, that's immensely helpful, especially when creating plots, because you'll just change around a few parameters, and you just press Control-Shift-P, and it just runs that chunk of script again. All right, we made it together. It's been a pleasure bringing this to you. I really hope that you learned a lot and that you continue working with R. And you know, if there's enough interest among us, perhaps we can form a R support group and continue mining our data for insights in order to better serve our users. And with that said, I'll turn it over to you with any questions that you have.
Great, thank you so much, Clark. That was again really interesting and informative. So now we do have time for questions, and if you haven't already done so, please go ahead and type your questions into the question box. We do have one to start off with. Says, hello, I am interested in applying R to better interpret and visualize counter report data. Could you provide some specific tips or tools on using R to effectively organize and visualize that information?
Oh, that's a great question. And one of my collaborators here at work is the one who really digs into our counter data and works with that a lot. So I wish that she was here to, she would provide a much fuller kind of answer to you. I will say that there are a lot of challenges with counter data, like especially with vendors that we subscribe to a number of databases within the single vendor, like EBSCO and ProQuest, for example. Sometimes it's hard to know if the usage represents usage for that single database or if it's spread across databases. So using recode can help you if you need to recode some of those database names to represent the data more effectively. And the same is true of different usage statistics. So there are some, like, you know, abstract views versus full text views. Sometimes you need to run some cleanup on those columns. I really, unfortunately, can't say too much more than that because I myself don't have much experience playing around with counter data. But according to my colleague, R has been incredibly helpful for her. Yeah, and I'll be happy to share. I'll get with her and ask if she wouldn't mind sharing her contact information, and she can give you some more concrete tips.
Okay, thanks. The next question is, what ILS system does UHCL use?
We use Sierra. Yeah, and but we're about to switch. At some point, I've heard to one of the next gen systems, but I've been happy for the most part with the quality of the data that I get out of Sierra. One issue that comes up, and I'm not sure if other ILS systems have this issue, is sometimes it instead of classifying each field as separate, it calls, as a single field, it calls them what are called repeated fields, and so they appear in separate columns, and that can really throw off the data. And it's just because of the way that they are querying their database. And so R is really helpful at cleaning up some of that messiness.
Okay. See if another question or two comes in, but I actually have one too while I'm waiting to see if others come in, which is, do you know if anything in like tidyverse or stringr can deal with character encoding issues? I know I've run into that with other tools in the past where like if things aren't in UTF-8, for example, it gets confused.
Yeah, and actually there are functions when you read the data into R, you can specify how it's encoded. And that way, that takes care of it kind of right away. So that would probably be the most effective way of, is like actually when you're reading that data in as an R object to specify the encoding scheme, and then we'll automatically, the output will automatically be encoded properly. Does that make sense?
Yes, it does. Thank you. We probably would have time for one more question if anyone has any last minute ones to throw into the question box, but if not, Clark said you'd still be happy to answer any email questions if anyone thinks of anything.
Oh yeah, definitely. You can just email me directly, and you know, if you do something really cool with this, or if you even need help on a specific project that you're working on, I'd be happy to serve as a resource for that. So hopefully we can, you know, stay informed and start our own little library R community.
Great, thank you. Okay. All right, looks like we're all set on questions for now then.
Okay, well, thanks very much, everyone.
Okay, thank you, Clark, and we are so glad you could all be with us today. You will soon receive a short online evaluation form. Please take a few minutes to respond to the questions. Your comments are very valuable and help the ALCTS Continuing Education Committee plan future events. The email will also include links to today's slides and recording, and you now have the opportunity to receive a certificate of attendance. That information will also be in the email. So thank you once again to our presenter, Clark Yakubakis, and thanks also to members of the Continuing Education Committee, Mary Reeder and I-Ping Chen-Gaffey, and to Megan Doherty from the ALCTS office. The support they provide make it possible for us to present these webinars. ALCTS has other continuing education events coming up. The ALCTS virtual pre-conference, The Road to Electronic Information Accessibility, will take place on June 5th. See the ALCTS website to register or find out more information. ALCTS also offers web courses, which are 4 to 6 weeks long, as well as 2-day email discussions. Check the website for more information on upcoming courses and discussions. Thank you all for joining us today. This concludes our session.